And in this video we will do an example of a KSP problem, a backwards KSP if you will. So the KSP for lead 2 sulfate is 1.8 by 10 to the -8th. So this time I'm giving you KSP, and the question is, what are the concentrations of the ions at equilibrium? Alright, so to do this we're going to have to write the dissociation of lead 2 sulfate. It's going to come apart into a lead and a sulfate. There we go. Lead 2 sulfate is equilibrium, lead plus 2, sulfate minus 2. Now here's what we're going to do for this. Kind of looking ahead, I'm going to have to write a KSP, and in KSP there's going to be two things I don't know, lead and sulfate, but I'm going to know what KSP itself is. Here's what I'm going to do. I'm going to assign to the amount of PbSO4 that dissociates the variable x. So there'll be x PbSO4. So how much Pb will there be? And how much SO4? For every one of these, we get one of these and one of these. So if I assign x to PbSO4, it's x for Pb and x for SO4, because we get 1 to 1 to 1 of everything. All right, so then if we write KSP, and I'm just kind of, because I ran out of room here, everything's going to be in kind of in one line here. So KSP is the lead 2 ion here times the sulfate ion from here. They have ones in front of them, so we don't have to mess around with that. But we assigned x to each one of those, so they're each x. So then that's x squared. And KSP was given in the problem right there, 1.8 by 10 to the -8th. So KSP equals 1.8 by 10 to the -8th, and it equals x squared. So that means that x will be the square root of that. So x is the square root of that, and when you do the square root of that value, you get this 1.3 by 10 to the -4th, and because it asks for concentration, I know that that's going to be in molarity. Okay, so it turns out that some of this does dissolve. This is not a tiny number for the KSP like it was for the previous one. KSPs can be really, really small. But remember that they only work if it's something that will not dissolve.